Hello, NSO development community. I'm Damiano Imperatore from Verizon's Global Technology Solutions Organization, and I lead a team of net DevOps engineers that builds automation for our internal network team that manages Verizon's retail and other admin networks. First, thank you for joining us as Houcheng and I demonstrate our CI chain that we built for our NSO-based automation to improve development efficiency as well as code quality. As net DevOps engineers, we carry the burden of managing a lot of very specialized network hardware, which poses a major challenge to developing a good CI/CD framework. To be successful, it all starts with a strong development environment. The most common ask I get from our development team is they want direct access to devices like routers, switches, firewalls, and so on, so they can fully develop and test their automation. I'm here at Verizon's Network Unified Communications Lab in New York, where we test and validate network hardware and software, as well as provide a development environment for our automation teams. Even with the lab of this size, access to expensive and sometimes very large equipment that you see behind me is not always easy to come by, and usually shared amongst many teams. This makes it very difficult to quickly develop quality automation in such a resource-constrained and sometimes uncontrolled environment. The second problem is using the same gear for our integration testing. That really reaches all the way down to the device level to ensure the automation works as expected and catches those pesky and annoying device OS level quirks and bugs that we run into from time to time. Although a NetSim is a handy tool, it does not replicate the real thing. And testing in production is never a good idea. To solve these problems, we built a simple, controlled, and stable dev environment that replicates production as closely as possible. First, we virtualize our network devices. Virtualization tools like Cisco Modeling Labs allows us to easily turn up virtual devices as well as network them together. Virtual devices can run the same or similar OSs as their physical counterparts, giving developers easy access for development. Secondly, by containerizing NSO, it allows us to fire up consistent NSO instances so developers can quickly build their own dev environments. These same containers can later be used for our CI process. To strengthen our testing process, developers use PyTest to prove that automation works as expected down to the device level, which is more efficient and accurate than manual testing. Next, we use source control tools like GitLab to trigger CI pipelines that automatically test committed code. This ensures every change is tracked and tested. Lastly, moving away from physical devices reduces cost and makes development more scalable and is a lot better than dealing with the headaches of sharing real hardware. Now that we've built a strong development environment, we can now use it for our CI system integration testing. Houcheng from Cisco's CX team will now demonstrate how we test NSO services using containerized NSO, GitLab, CML, and PyTest to ensure we have high-quality code that is ready for production. Houcheng, take it away.
Later on, it will map into our demos later. So let's look at common scenarios. As an NSO developers, I make a change. When I make this change, should I push this to the production or not? Should I work more like a cowboy style? I just push it and then test it in the production environment? Or there are some better ways to help me with this. The CI process is here to help. In a generic CI process, usually when you make the change, then you push to a source control systems. The source control system usually is a Git systems, and the system will trigger CI pipelines. And the CI pipeline will go to the build stage first. When it is in the build stage, you compile the NSO service packages and make sure NSO is ready, and also the device under test is in the state that you want. Then after that, you move on to the test stage. In the test stage, you can have all different kind of testings. including dry run test, commit test, integration test, system test. And after you run all the tests, then you can have a report. The report will back to the CI, and CI can notify the users it is good or bad for all the testings. And after the developer examines all the results, then they can decide it if they want to go with the change or not. And before we look at the demos, I want to emphasize one thing. We all know that one size does not fit all. If you look at the CI tools market right now, there are a lot of different choice. I think it all based on your team's needs and what's the object of your CIs. And even more, there's a budget considerations. And what are we going to demo? We use the GitLab using the Cisco Modeling Lab and plus the GitLabs to do our CI chains. And it works and meet our objective. And then we're using those CI chains to run the NSO testings. So the next thing, that's go into the demo part. As you can see that right now on the screen, this is our CI chain environment. I divide into 3 blocks. On the top left is the Cisco Modeling Lab. On the top right is the regular terminal. And at the bottom of it is the GitLab environment. So what we try to do now, we are going to the first stage. We'll make some change in the terminal side. As you can look at it in the terminal, we try to commit a change. So right now we make some change. And the next steps, we try to push it to the remote Git repo. And in our case, here is the GitLab. As you can see here on the bottom of it, a new pipeline has been triggered. And the trigger pipeline, you can see there are different stages inside of it. It's a build, and then testings, and also the cleanup. We can click into it to see what's inside of these pipelines. So inside this pipeline, you can see the first thing is the build stage. You compile the NSO packages, and then you try to load the configurations into the CML to have your device under test ready. And later on, we will look at it. And the next thing is check the connection between your pipelines and the device under test. And then you move on to the testing stage. You want to run different kind of testings in your testing stage. And at the end of it, you want to clean up everything so you can back to the original state. So let's focus on the top left here because we just passed the building stage. We are moving on to loading the device stage. So right now at the beginning, there's no topology there. So right now you can see the pipelines just talk to the CML and then bring up a topology called 2CSR1KV. And this topology has been brought up by the API from the GitLab. And then you can see the topology here. We can click into it and see what's inside of these topologies. In this topology, it has two CML, and you can drag it and make any different of the connections in the CML. And also, we can take a look of what's the status of the node, because right now we just have it started. So right now it's in the started state. And also in the CML, you can see there are a lot of different tools can help you, including the terminal. You can look at the terminal of each node, and also you can load the different configurations to have a more controllable environment, so that your test can base on the configurations. And right now the device has been brought up, and then the job success for loading the configurations. So let's go back to the state of the nodes, and you can look at it. Both of the CSR 1 kV nodes are booted. So the next stage is the checking the connections. So when you are in the checking connections, you are checking the communications between your pipelines and the device and make sure the communication is all good. And moving on to the next testing stage. The testing stage, you can see we have two jobs running together at the same time. That's based on the NSO Dockers, containerized Dockers, so that we can running both of them at the same time. We also set up the NSO environment at the beginnings, and after everything is all ready, then we will start with the PyTest in our case. We have the two NSO service packages in these demos, and they were running testings together. Later on, you will see the different logs from the two different testings. So let's jump into the first ones. So in the first one, the first stage is try to bring up the containerized NSO. This is the first one. And if we click to the second test, and this one goes a little bit faster. Right now, this NSO has been brought up, and then it is into the stage of checking if NSO is ready to go. It takes some time to bring those NSO up because it needs to go through all different phases to make sure the NSO is all ready so that we can continue with the NSO service packages testings. So let's go back to the first one to check it again. So right now, the phase 2 of NSO is ready, and we try to connect to it and bring up the NCS CLIs. If we look at the other ones again, and then so for now, the NSO packages are up. You can see we have one net and two service packages. It shows the version of it. And the next thing is we have onboarding those CSRs into the systems. So this is just common onboarding process. The first thing is fetch the SSH key, and then you will do a sync from to getting the configurations from the devices into NSO. As you can see on the screen, right now the sync from is finished. It's running the testings, and we are using the PyTest to test this. So you can see here the PyTest passed for one of the packages. And when we go back to check it, and both of the tests are finished at the same times, and then we move on to the cleanup stage. In the cleanup stage, we will try to remove the topologies from the CML. And you can see here, the two CSR 1 kV topology is gone. And we are back to the original stage before we run the pipelines. So when the next time when we run the pipeline again, we will start with everything cleans, and then we can have a controllable environment to run it. And at the end of it, I want to show this is the report from the GitLab. You can see you have a different pipelines running and the running results, and users can base on these results to see if they want to push the changes or not. Or even more, you can have systems automatically to check if you want to push those changes to the downstreams, or maybe we want to have a continuous delivery systems. Yeah, we just finished our demo. I want to give a quick recap of each stage and what's the properties that we were looking for different stages in the CI pipelines. So the first things is the source control and pipelines. and we want to have source control systems. In our case, we are using the GitLab as the source control systems, so that this Git control system can track the changes, and then we can cooperate it with different developers and make sure the code qualities. And also, we can streamline the testing and delivery by triggering the pipelines. And the next thing is the build stage. In the build stage, we use containerized NSO so that we can run the NSO testing in parallel. And also, we're using the Cisco Modeling Lab, CML, so we can have different topologies with the loaded config, and then we can control the load config as the green field or brown field. And after the build, then we can go for the testings. And in the testing part, we use the PyTest to run the test. And we have different kind of testings. Specific for NSO, we have the dry run test and the commit test. For the commit test, we compare the expected configurations after applying the NSO services onto it. Then we can make sure the configuration is all correct when we automated all these kind of tasks. And the testing is also scalable because with the help with the containerized NSO. And back to the result part, you want to see from the pipelines whether you go through the whole stage, and if everything is all correct, then you can pass the changes. And furthermore, if you want to have continuous delivery systems, you can combine the CI with the CD. So when the CI passed, then you can continue deliveries to your downstream systems. So this is the whole concept of the CI that we used, and I demo it in the DevNet. Then you can have a quick look from the DevNet to get the idea of how it works. I will hand it back to Damiano to let him talk about how we get from this CI process. Damiano.
Well, Cheng just demonstrated how we use the GitLab CI/CD pipeline to trigger integration testing all the way down to the device level to ensure we have high quality code. And this alone is a huge time saver versus testing manually, which is an administrative burden. It's ever prone and not ideal as we expand our automation capabilities. As the number of NSO services grows, the CI testing cycle becomes a vital part of the process, as everything with NSO needs to work together, from the NSO version to the net versions, as well as the service code that runs on top. We can also use the same CI process to test across multiple NSO versions or even net versions with ease. Again, saving countless hours of testing and bringing the value of automation to production in a quick and efficient manner. Thank you, and we hope this demo helps you with your automation journey. If you're interested in learning more about our demo, we have created this DevNet link where you can try it on your own. In this DevNet sandbox, you will find out more information on how we put our CI pipeline together, including how to trigger your own pipeline via GitLab, launching containerized NSO, building a virtual network with CML, and finally, testing with PyTest. Thank you for taking the time to join us today.
Hi, I'm Ragvi Reddy Poreddy, working as a software engineer here at Cisco since 2018. I started working as a UI developer in Taylor Function Pack team for service provider VU. We use NSO to build various core function packs like SAE, Transport SDN, and NFVO. I always enjoy working on complex and challenging issues. It's always about improving. Let us know your feedback, we'll enhance it more. Thank you. Happy Developer Days.
We have so much activity on our live chat, and it's great to see that many are interested in just this use case. It also resonates very well with the poll that we just did, where we asked for the most popular automation use case. So, Damiano, have you met your goal now as a lead for the DevOps team? in terms of code quality and developer efficiency?
With automation, it's always growing, right? So you're never in a static position. You're always learning and improving on things. So with our automation and our testing, we're constantly improving it. So we call it continuous integration, but I also can call it continuous improvement. So we're always making it better, right? We learn from our mistakes. When we think we tested it, we go to production. Maybe there's a minor thing we missed. We put that test back in the testing process, or we put what we found in the testing process, so that error never happens again.
All right. So one question to follow up on that: what has the hardest part been with building a CI testing process?
I think the hardest part, as we mentioned, the dev environment is huge, right? That's you want that solid dev environment. But really, on top of that, you need to have a vision of what you want to do. How do you want these tests to perform, and what you want to perform, as well as basically structure that so it fits your team's goals and their strengths, right? Whether it's Ansible, PyTest, whatever, that framework needs to function and be understood by everybody in the team. And you need to make these tests reusable. So as you build these services, you can reuse these tests. You're not rebuilding the entire CI framework for every single service you're building, right? You want to just continuously reuse it, right? So everybody understands it. It's easy to update, right? That's important. Make sure it's easy to update, because if you make it very difficult and it's hard to update, it becomes very cumbersome and it doesn't work. So it needs to be repeatable, reusable, and easy.
Yeah, makes a lot of sense. I think we have a question for Houcheng. Can we download Cisco containers from the Cisco website? As someone asked.
Yeah, sure. I think we are using the official Docker NSO containers. I think you can look it up in the GitLab, and also I think there's a mirror in the GitHub. Yeah, you can download it from there. I think we benefit a lot from the communities. I think that's share repos. I think all the community members can look at it, and if they are interested in using the containerized NSO.
Okay, good. So how would you go about achieving the same thing if you don't have the virtual instances of the router OS? Can CML use the native AUX NOx version?
I think for the CML, I think that's the good part for the CML. I think it's based on the version of the different devices. For example, for the Cisco iOS, you can almost migrate the whole similar things to the CML and test it there. I think in our experience is very close. I think 98 or 99% close to the hardware parts. And for the Nexus, I think for that part, we probably need to check with the CML BU and look at if they have the virtual version of it onto it. But I think most of the Cisco devices are covered by the CML.
So yep. You could do it with hardware devices. The issue is with hardware, you have to get it back to a known starting state at all times. So CI, as your CI process goes, it's starting from a known state. And that's sometimes difficult. You can do it. It's a little bit more difficult, but you can do it with real hardware, using the same CI chain for real devices.
Okay. So one last question I think we can do. How do you verify the test results?
For verifying the results, we have different kind of testings. So it's based on, for example, the NSO has the dry run test, the commit test, a system integration test. For those tests, we have a predefined result. For example, if you are doing the commit test, we have predefined the expected result of the device's config. So when we do the commit test, then we will compare the running result with the expected device config and make sure they are the same.
Okay, great. I think our time is up, and I'd like to thank you so very much for this presentation and the demos.